So we notice that if we want to complete the square, if we have something in this form, x squared plus bx, if we cut this b in half and square it, that's what we need to add to make a perfect square. So let's try that. Here we have a function, a y equals 2x squared plus 20x plus 6, and we want to use this to end up with vertex form. Remember, vertex form is this: y equals a times x minus h squared plus k. And so we notice that we have this parentheses squared. That's what we're going for. And we just did a bunch of completing the square that ended up with some parentheses squared, a binomial squared. So let's see what we have. We have y equals 2x squared plus 20x plus 6. And what we're going to do here is we're going to kind of separate this these variable terms and just kind of ignore this constant over here for a moment. And we're going to factor just this part. Okay, now watch carefully. The key is that everything we write down is going to be equal to what it was before. Okay? So we just separated that out. It's still equal to what we had up here. If you distribute this out, you'll get right back where we started. So now we've got these parentheses here. This is not a perfect square, but I would like it to be. Because if this was a perfect square, I could factor it to make it look like x minus h squared. I already got some kind of k going on over here and an a value. So we ask ourselves, what do we need to add to make this a perfect square in here? Well, we need to add half of 10 squared, which is 25. So let's go ahead and do that. So let's take y equals the 2. We're going to take our x squared plus 10x. Let me leave a little space. And what we're going to do is we're going to add 25. Well, wait a minute. You can't just add 25 because now it's not the same as what it was before. So we're going to do something a little clever here, and we're going to subtract 25 at the same time. So, is it still equal to what we had up above? Absolutely. The 25's cancel, and we got this. We distribute, and we're right back where we started. So, this is still not a perfect square because this minus 25 is kind of a pain in there. So let's pull that out of the parentheses, but we got to be careful. That's not just a minus 25. It's a 2 times minus 25. So we can rewrite this as y equals 2x squared plus 10x plus 25. And I'm going to pull that minus 25 out, but we've got to use the 2 times 25, which is minus 50 plus 6. So this is still equal. Again, the 2 times the minus 25 give us negative 50. And we see that this is a perfect square trinomial. Half of this squared is 25. And it's in that nice, neat form that we wanted. So we can now factor the parentheses. This is x plus 5 squared. And minus 50 plus 6 is going to give us minus 44. All right, and there is our equation in vertex form. And we can see that our vertex is negative 5, negative 4. And it's got a vertical stretch by a factor of 2. And the axis of symmetry, well, that's the line that goes right through the vertex. That's x equals negative 5. So that's how we can take an equation that's in standard form and change it into vertex form. Now, if we do that with a generic quadratic equation, take y equals ax squared plus bx plus c, and we complete the square, go ahead and try it if you want to take on a challenge. It's not that hard. I bet you can do it. But we're going to end up with this big, ugly thing right here. And we see right here that the vertex is at negative b over 2a. That's the x-coordinate, or that's the axis of symmetry. So in general, if we have an equation in standard form, y equals ax squared plus bx plus c, the axis of symmetry is at x equals negative b over 2a, and the vertex is negative b over 2a. That's the x-coordinate. Plug it in and you get the y-coordinate. So let's wrap it up with finding the vertex form here and the axis of symmetry here. So we're going to do the same thing. we're going to take y equals negative 3x squared plus 15x plus 6. We're going to break off this variable parts, and we're going to factor out the negative 3 because we need it to be 1x squared. So we've got x squared, and negative 15 divided by negative 3 is negative 5. I'm going to leave a gap here for some thinking. And we want to complete the square. Well, what are we going to add in here? Well, it's going to be half of this squared. Okay? So half of 5 halves, or half of 5 is 5 halves, and we're going to square that. So that's going to be 25 fourths. But we've got to also subtract 25 fourths. That's 5 halves squared. Okay? Now, this is not getting too pretty, but that's all right. We can continue. Let's pull out this minus part, and we're going to have negative 3 times x squared minus 5x, and we're going to leave the plus 25 fourths, and we're going to pull out negative 3 times negative 25 fourths, and, well, that's going to be negative 75 fourths plus the 6. Okay? And, well, good news is that the inside is now a perfect square because we forced it to be. It's going to be x minus half of that middle term, 5 halves squared. Okay, we're going to add these here. 6 is just 24 fourths, so negative 75 plus 24 is going to give us negative 51 fourths. So, there you have it. We've got the vertex at, well, first the axis is at x equals 5 halves, and the vertex is at negative or positive 5 halves and negative 51 fourths. Now, that'd be pretty tough to see on a graph. So even though it's a little bit of work here, we can find that vertex nice and exact with some nice fractions there. All right? Now, what if we use the formula negative b over 2a to find the axis of symmetry? Well, x equals negative b over 2a. The b in this case is 15. The a is negative 3. So this is negative 15 over negative 6, which we can simplify. Oh, that's 16. Dividing by 3, we have 5 halves. So there's our axis of symmetry, x equals 5 halves. Okay. Oh, little typo here. This is supposed to be the same function. That's supposed to be a 2 there. 3x squared. All right, so let's plug that in to find the vertex. Well, we want to find f of 5 halves. We're plugging in 5 halves. That's negative 3 times 5 halves squared plus 15 times 5 halves plus 6. Oh boy, lots of fractions here. Well, we have 25 fourths times negative 3. Well, that looks familiar. That's negative 75 fourths. And here we have 15 halves. 15 times 5 halves, that's going to be 75 halves plus 6. Okay, now we got to add these together. Maybe we'll go ahead and get a common denominator real fast here as the fourths. And adding that together, well, we're going to get 75 plus 24, that's going to be 99 fourths. Now, something came out a little different. And do you see my mistake up above? 99 fourths. There's our vertex. So what happened? Well, up top here, what happened was this. I had a negative 3 times negative 25, which should give me a positive. Did you catch that? You probably caught it a long time ago. So that should be positive, and that's going to give us this 99. So we end up with negative 99, actually positive 99 fourths. So 99 fourths is the correct answer there. All right, well, be careful with those fractions. Watch out for those negatives and positives. That's how it works. We can get vertex form, or we can use the axis symmetry, negative b over 2a. Both will get us those valuable points for the vertex and the axis of symmetry. Good luck.